here, and we'll go from there.
Well, I can't hear it.
I can turn it on.
Yeah, can you hear me okay, everybody?
Yes.
Yep. Awesome. Yeah, so yeah, Roger Eberhardt, my contact information there is at the bottom of my opening slide, and I'll show that again at the end. I suspect we'll have a few questions we won't get to, and if any of you want to discuss more about this whole venture, you're absolutely welcome to email me anytime. And for any purpose. This is one of 3 solar stories I'm going to do. I've got a off-the-grid ground mount system that I'll talk about today that I use just to charge an electric car. And then I also have a small system on a tracking mount that charges my yard tools that I'll talk about later. And then I also have a large system on my garage that is grid tied that's been operational here for about a year. So my solar story tonight really starts with a car. This is the end use of the solar that I generate. This one is an Audi Q5 plug-in hybrid. It's my 3rd plug-in hybrid. My wife and I are huge fans of electric cars and specifically plug-in hybrids. This particular one is relatively new to us. But it operates basically like any plug-in hybrid. It'll run for a while locally, or for a while, in this case, about 32 miles on electric power. And then the gas engine seamlessly takes over, especially if we're on trips.
It has a gas engine?
And in this particular one,
no, this is a hybrid.
We can do all of our local commuting, all of our local work on electric only. And then when we take trips in various places, the gas engine turns on, and of course that eliminates any aspect of range anxiety or concern. We didn't build our system originally for this car. We built it for Ford Fusion Energy, which was our first plug-in hybrid.
I hope so.
But in this case, we've moved on to an SUV that has turned out to be pretty nice. And I'll talk a little bit more about that a little later. So my system looks to me like I'm going to be cutting off a little bit of the slides here from the images of folks on the right, but maybe you can see the whole thing, I'm not sure. In any event, this is a drone shot of my solar panels in the backyard.
Not very aesthetic.
It's, I have 2 arrays and a bit of an odd arrangement because I have site-specific.
Excuse me, Roger. I'm sorry. Could people put mute on so that we can hear you? Because some people don't have their mutes on. I'll mute so we turn off the dog.
Oh, thank you. Yeah, that makes my dog bark. Anyway, 2 solar arrays for a specific reason. I have a lot of shading that I have to deal with, and this array arrangement helps with the shading. And I also have a septic system in the middle of my backyard that I have to avoid. So I separated my panel arrays into one that faces southeast and one that faces southwest. North runs right down through the middle of them, straight between them. And this arrangement works pretty well. The east array, southeast array cooks real good in the morning. The southwest array cooks real good in the afternoon, and they're both tied into the sun. In the middle of the day, I can charge the batteries, the storage batteries, with about 2.5 kilowatts of power. And so I'm pleased with the arrangement. If I had a better site-specific situation, I would not do this. But in this particular case, it works okay. And what I thought I'd do here is kind of follow the path of the electricity in describing how this works. It starts with the individual panels. I bought these panels from CBS Solar up in Kopamish and put them on a very simple but sturdy wood and cement base at the angle that matches my latitude here in Haslett. And these panels are 250 watt panels each. They feed into, all of 12 panels feed into a combiner box. which is not actually high voltage and it's not actually dangerous because this is all low voltage DC equipment out here. But I put that on there to remind myself that I'm working with electricity and I have to keep thinking all the time. I learned a lot about electricity from my dad, who was a professor of electrical engineering. And the basement in our house at home when I was growing up as a kid was always full of a variety of weird electrical equipment and test equipment. And I always like to say I'm lucky to have survived my childhood because I did so much stuff down there playing around with electricity. In any event, I'll point out this little device over here on the side. It's a lightning arrestor. I learned the hard way that off-the-grid systems need to be well grounded and protected from surges. Lightning is a real bugaboo of these off-the-grid homemade, home-built systems. You can get some pretty nasty surges from lightning strikes that are quite a ways away that can do a lot of damage to electrical equipment real fast. So anyway, all the power comes in here. It's combined into one big wire that goes into this system, which is in the garage. And I'll spend just a couple minutes on this slide because there's quite a bit going on here. The central part of this system in the middle is the master control where all the wires come and go, both DC in and AC out. The electricity from the panels goes into this charge controller, which controls the charge to the batteries and protects the batteries from being overcharged. There's a variety of circuit breakers on here for protection of overcurrent. And up on top here is the inverter, which takes the DC power and changes it into AC power. That goes over then into my circuit breaker panel where my car charging cable plugs in, and that's the device you saw that was plugged into the car a few minutes ago. This is something that I purchased as a pre-engineered, pre-built system from a company in Arizona called Northern Arizona Wind and Sun. And they shipped this to me on a pallet, all just like this. So all I did was screw it on the wall and hook the solar panel wires into the charge controller and the batteries, which I'll show you in a moment, into the master control panel, and the AC output into the circuit breaker panel. So the wiring on this system was not mysterious or unusual or odd. They make this system specifically for this purpose. And for those of you interested, this is a 24-volt system, which I chose for a variety of reasons. But 24-volt DC batteries and 240-volt AC output, or 120-volt. But I did want the 240-volt AC output so that I could do level 2 charging on the car. Up here on the right is a separate charge cable that's connected to the utility so that when the sun doesn't shine, I can charge my car with a charge point charger or a charge point system. And so I don't have any, in this case, sun anxiety, because I can plug the car into a separate utility if I need to. So I guess I don't want to overemphasize how easy this was, but it wasn't all that complicated because I purchased the pre-built system. And I also would point out that there are 2 more lightning arresters here, one for the DC and one for the AC side. So and there's a giant ground wire running down here to a ground cable that helps protect the system from a variety of surges. So from there, the electricity, from the charge controller, the electricity goes into the heart of the system, for an off-the-grid system anyway, which are the batteries. I have 8 deep cycle storage batteries that are the lead acid batteries that are actually golf cart sized batteries. These are the AGM batteries, which I chose for their low maintenance and ease of care. With large cables between them. This is a 24-volt system, and the system is when it's running at full tilt, it can use a lot of amps. So when you wire this part up, you have to be careful to not do any accidental DC welding. There's a lot of power involved here. And it also is important to keep this well fused. This system here was designed originally for our Ford. It will actually store enough electricity for about 1/3 of the Audi batteries. So I'm in the process right now of considering the possibility of upgrading this to lithium and doubling the capacity. But my negotiations with Arizona Wind and Sun are in process, but probably going to be a few months out. Anyway, there's nothing mysterious about this. The batteries are wired up. They're 6-volt batteries wired such that I get 24-volt output in 2 banks. And that simply goes into the inverter for conversion to the AC that the car needs. No care for this kind of battery at all. They just sit there and work. I expect the system, these batteries, to have normally lasted about 5 years, and they're currently about 3 years old. So they do have some life left in them. So it all ends up in the car. Plug-in hybrids as well as electric cars all have a standard charge port, so you can plug any wire in here that you want to, or any wire that's available. In my case, I'm using 240-volt level 2 charging at a relatively small amperage. I don't like to push too much amps through my system, so it takes a while to charge the car. It's not a speedy operation, but in the use that my wife and I have of it, it's completely functional and works really, really well for our local driving. The system has a lot of different ways of monitoring what's going on. This is the display on the charge controller, which is showing right now that I'm getting 670 watts from the PV array going into the batteries. This is actually yesterday, a cloudy day, or part of an early morning cloudy cover. So I'm not putting out too much power right now, but 670 watts is fine. I also have a display and a monitoring system on the inverter. And in this case, it's showing the batteries were pretty fully charged at 27.2 volts. And I'm not actually using this system right now, which is why it reads 0 amps. But there's a lot of different ways of monitoring this and determining how you're doing and tracking usage and the system, which I found to be fun. It's been real interesting, and I'm kind of always running out to the garage to see what's going on. My Magnum Energy system is a little bit dated in that it's not well tied to the internet, so I physically go out to the garage to check on things, but more modern inverters and charge controllers are all internet connected, and you can just sit and watch everything on your smartphone. So I had a number of different possibilities of talking about data, and I decided that rather than doing a lot of numbers, I would talk about the sort of the practical aspects of this and use some specific examples. The car we're driving right now, the Audi, uses about 2.4 kilowatt hours for a round trip to our local park for a dog walk. So every day, my wife and I load up the dog and we go for a dog walk. And unless it's really cold and the car uses power for heating, we use about 2.4 kilowatt hours. And the solar system that I have, I think I mentioned earlier, can produce about 2.4, 2.5 kilowatts in full sun. There's some losses in the system. That's why it's not a full 3 kilowatts, which is theoretical from the panels that I have. So it takes about 1 hour of sun, full sun, to generate the electricity for my park trip. And that translates into a lot of different other trips. For example, our trip to our local Myers is about 4 times as far. So it takes about 4 hours of sun to generate the electricity for a trip to our local Meijer. And I'm not sure you can see the part to the right there, but if you can, what it says is that although it's too early to tell since this particular car is too new for us, it looks like we're going to be able to generate most or all of the electricity we need for local trips for the Audi for about half the year, from about equinox to equinox, March to September. And then the other half of the year, during the late fall, winter, and early spring, will be primarily but not exclusively on the utility for running our car on electricity. So I followed the path from the solar to the car, talked a little bit about the data. There's a lot of great resources available for those of you that are interested in considering some of these for yourself, some things like this for yourself. Although I don't necessarily recommend an off-the-grid system, it can work pretty nicely if you have a specific use, like I have for the car. John Sarver mentioned this website, PV Watts, the National Renewable Energy Laboratory, which is a wonderful system for determining how much power you might be able to produce at your home or at a specific location. I did not use this back 3 years ago when I put my system in, both because I didn't know about it and also because I probably would have been too depressed. I have so many trees that I think the system might have spit out some pretty dismal results for solar here. Anyway, in addition to the information you can gather yourself about site-specific stuff, we do have a arrangement here in Meridian Township. I think John mentioned that we have now more than 3 homeowners that are willing to talk about their systems with others. It's more than just these My Solar stories, and you're welcome to contact John through his email if you're interested in getting advice from a variety of folks. My system is the one here in the middle. My entire garage roof is covered with solar panels. In fact, it doesn't even look like I have a roof other than panels, because I really don't. And then I should also mention the Great Lakes Renewable Energy Association has a business directory with solar installers, some of whom are familiar with off-the-grid systems, but most of them do on-grid work. And they have a variety of other functions, including advocacy and newsletters, and maintaining the Michigan Solar Users Network, which you're all familiar with already. So that's my 20-minute shtick. A little bit about what I've done and why I have done it, and a little bit about why it works. And I think might be time for questions. I'm not sure exactly how to operate questions, but let's see.
Why don't you just let us ask?
Well, that's too easy. We have to make it more complicated. Yeah, why don't you go ahead and ask questions?
Can I ask? I'm John Gorley. I've got my video turned off because my internet connection is too slow for real good
I hear
Zoom
you.
meetings.
Yeah.
I wanted to ask you a couple of things. One is that it sounds like you only have one charge controller, which means that when one of your panel groups is shaded, you're not going to get full efficiency out of the other one. Did you consider having a second charge controller?
Yes. I had a lot of really, really good technical support from Northern Arizona Wind and Sun in designing and putting the system in. Of course, what I would ultimately like to do is have a charge controller per panel, because that would really, really help the system related to the shading. But ultimately, they encouraged me to go simple and to not worry quite as much as I might have otherwise about shading. And because of the arrays and the way that I have them pointed, I'm okay on shading. It's a problem, and it's a problem with any system where you have a string inverter, a single inverter, or even 2 inverters. But of course, the system that I have that's on grid is microinverters, which is 1 per panel, that makes a huge difference in the shading issue. But you brought up a good point. and I just decided to make it simple and go with one.
Where are you located? Raj,
Yep.
where are you located?
So I'm on Piper Road in Haslett.
Haslett?
Yep. Uh-huh.
Okay. I'm down in Bloomfield Hills. Our company, Power Home, is based in Troy.
Yeah, good.
So Jim introduced me to the group here, so I appreciate you guys having us all here to talk about this.
Oh, you bet.
Thank you.
Yeah, you bet.
Are the other guys here in the industry also?
I guess not tonight.
Okay.
Roger, are those two arrays wired in parallel to the one charge controller?
Yes. The panels are wired in a combination of series and parallel, partly to address the shading issue, but partly to get enough voltage into the charge controller to make sure that I keep the batteries well cared for. So it's a little more complicated than saying that they're just wired in parallel, but yes, they are. Those two arrays are paralleled.
And so how many, so some of the, it looked like there were 6 panels on each array. So are there 2 or 3 in series?
There's 3 in series, and they are in parallel.
Okay.
So I've got 4 parallel strings.
Okay, great. And those you have a combiner box on each of the 2 arrays, and then run from each of those into the garage?
No, everything goes into one combiner box. So the electricity travels from one array to the other. It's approximately 30 feet of extra wire for that one array to get over to the combiner box.
Okay, I got you. And so then there's one run from that array into the shed or garage.
Yes, from the combiner box, there's one wire that handles all the amperage that goes into the garage. Yep. And that's all underground in metal conduit.
Roger, do you have a problem with snow accumulating on those panels? They don't look that high off the ground.
I have a problem with snow building up at the bottom when I brush it off.
Yeah.
Because they aren't very high off the ground. Because they're ground mounts, I can easily get to them. And,
Yes.
and I've got a nice soft brush that I can use to brush them off. But they're not high off the ground, and I sometimes take my snowblower down there and blow the snow out from the base of them.
Okay.
There's a lot of interesting considerations for ground mounts, one of which is zoning. And I had a 6-foot height limit. And what I could build here without running afoul of zoning or building permit situations.
Yeah.
So the top of the back of my panels are 6 feet high. Above that, it's considered a fence, and then you have to get a variety of other considerations kick in. So I knew all that going in. I asked all the questions up front so that I knew what I could and could not avoid.
Sure. Great, thank you.
I'm Shannon Merton, and I'm new to this whole idea and discussion, and I appreciate being invited. I was just kind of curious if this kind of system could be used for backup electricity, like if you didn't have power or something and you didn't need to use your generator, like a gas generator.
Yeah, absolutely. In fact, I have a cable, a 4-wire 10-gauge cable long enough to run from my solar system into the generator input on my house. And if the power goes out, I can just flip my transfer switch in the basement and run my house on this solar system, no problem. You do have to have it into a transfer switch, and you have to have it's basically a generator input with a transfer switch, but it's a simple connection. relatively easy to do. And because that tied into my home electric panel, that the transfer switch part of it, I had help with from a licensed electrician who actually redid the whole panel for me in my basement. But that's unrelated to this. It's just that I had a transfer switch put in. So yes, with an off-the-grid system, you have the ability to power at least some circuits. I mean, this system isn't going to power my air conditioner or high amperage uses in my house, but sure, I can keep the house running no problem for a while, essentially forever if the sun shines.
So this is John Gorley again. Speaking of transfer switches, do you have a transfer switch for powering your car charger from the utility power? Or do you just plug the car charging cable into a utility connected outlet?
The latter. The charge point EVSE station that I have is totally separate from the solar. It has its own wire, its own circuit breaker into the garage panel, and is no relationship at all to the solar. And that was an agreement I had with the electrical inspector that I don't make any connections between the utility and the off-the-grid system, including the auxiliary or utility car charging station.
So that was going to be my next question, but you answered it.
Yeah.
There's just kind of a general question I have, and I don't know that you can answer it, or maybe there's somebody else on the call who can. That if you have a grid connected solar system, but if it's set up so that you never put power out on the grid, does that require the grid interconnection agreement nevertheless? In other words, if you draw power from the grid sometimes but never put power on the grid, do you
I understand the question and I don't know the answer. It would seem that you wouldn't need an interconnection agreement if your inverter were not grid interactive, but I don't know that, and I would be afraid to ask.
I'm pretty sure.
I can give you a little bit to answer that question.
Oh, there you go. Okay, I got it.
Say you need an interconnection agreement, or if you
So-
have a public service.
Okay.
That doesn't mean that you could get away with not having one, but I'm sure, like Roger says, sometimes you don't want to ask questions. I would guess that you're supposed to have an interconnection agreement in that situation.
Hello.
In the state of Michigan, my company puts in 250 systems a month residentially. We work with virtually every power company in the state. And if you're to be connected to your meter at all, you have to have an interconnection agreement. So that's something we do with every client.
Yeah.
Hello.
Okay.
Hello.
Hello.
Hi,
Can you
Steve.
hear me?
Yeah,
Yes.
hi, Steve.
Steve Smiley here.
Uh-huh.
Yeah, I go on and off the grid, and you don't need an interconnection agreement as long as you're not backfeeding. So, although when I go off, the meter goes dead, there's no recordings, and since we're remote monitored, sometimes the meter guy will show up and say your meter's broken.
Okay.
You don't need any connection agreement if you're just either on or off. As far from my experience, I made some chat questions. Can you see those?
Let's see. Can I see those? Yes, I can.
Can you answer those?
Yes, I can. My inverter is 120 volt, 240 volts. It's rated at 4,000 watts. And a level 2 charger gives me the capability of charging much faster rate than a level 1 charger. I don't necessarily use that capability, but I can if I need to or want to. And I sometimes want to. If the sun is full shining and I'm getting lots and lots of amps into my system, I can kick the amperage up. I do have an adjustable system for charging the car. And your answer about the grid, I'm not connected, never connected to the grid at all with this system. So when I'm charging, I have no connection to the grid, and I don't have to worry about disconnecting to the grid. And the last question, the level 2 charging can take what the converter can produce, yes, because the charger itself is actually in the car, and the car is capable of pulling pretty much whatever the outlet can provide. There's a little backfeed signal with the charging cable, charging system that tells the car how much is available. That's the case if you don't have a charging cable like I have. The charging cable like I have sets a specific amount and doesn't let the car decide. So I set the number of amps that I want going into the car, and that's what it allows, up to the maximum that the inverter can produce, which in my case is 4,000 watts.
Roger, could you talk about how you manage the state of charge of your battery bank? Like in the wintertime, say, there's not so much sun and you're wanting to drive your car more or use more energy. Do you fill up the battery and leave it full for the life to have better life of the batteries? Or do you let it go lower because you wanted to charge it some? How do you manage that type of thing?
In the winter, it's primarily the former. I've had some experiences with battery sulfation at my cabin in the Upper Peninsula, where I also have an off-the-grid system. And battery sulfation can occur pretty quickly if you leave a battery at a lead-acid battery at a discharged state for too long, or don't, at least periodically, fully charge it. And in the winter here, I do have enough electricity to keep the batteries charged and occasionally charge the car in say, in the depths of January. But in the winter, specifically around the solstice, the winter solstice, I'm really focused more on battery preservation than I am on charging the car, because the batteries are expensive, and it's worthwhile keeping them charged up and preserving them. So sort of the long answer to your question is that when the sun's shining in the winter and I've got good light on my panels in the middle of the day, I'll plug the car in, no problem. But under normal circumstances here, you know, we live east of Lake Michigan, we're going to get clouds all winter. And so I spend a lot of time just simply preserving the batteries. And in that instance, I've got a pretty good battery monitoring system that runs off a shunt that tells me pretty accurately what the batteries are doing. And I can keep the voltage up to where I'm happy.
I don't know if everybody can see the remaining meeting time up on the top, but just so you know, we got about a minute and a half left. And before we get cut off, I'd like to thank everybody for coming. And next week on Thursday, David Arnosti, who was with us earlier, is going to be talking about his rooftop solar. And I've scheduled a whole bunch of other people through May into June. So it looks like we'll be able to continue this series for anybody interested for the foreseeable future. And I look at about a minute left. So Roger, do you have any parting words?
Not specifically, but I have another question here in the chat box.
Go for it.
The batteries are not in an environmentally controlled space, other than the fact that they're in the garage. And I do have a thermometer where I monitor the temperature where they are. And where they are in the garage, it doesn't go below 40 degrees unless we have a really unusual temperature. And because they're lead acid batteries, they don't have a temperature limit. I can operate them at any temperature that I want to. It's one consideration for lithium batteries. They don't charge below 32 degrees, so you have to be careful with lithium. But my lead acid batteries are very tolerant of a wide variety of temperatures. So I can leave them in the garage and not have a problem with them. it's appropriate, I think, John, to end this conversation on batteries, because that's kind of the heart of an off-the-grid system.
Yeah, absolutely. Well, I think that's